Okay, so the next topic we're going to cover is using linear relationships, which basically ties in all the information that you guys have learnt throughout the chapter. So the first thing that we're going to start looking at is defining a variable. In mathematical word problems that contain variables, we need to choose a suitable pronumeral to represent a variable. In measurement, we used h to represent the variable of height, v to represent volume, and t for time. So for the first question, we're defining the two variables involved. If I look at the first one, I'm looking at volume, and also in the water the tank increases during the day. So that's obviously going to be looking at time there. So I can write down time and volume. And really it's up to you guys to what they do equal. So T for time is pretty straightforward, and V for volume. Next one we're looking at is speed and distance. So I'm going to write down speed, and we'll make that equal S, and distance to equal D. Okay guys, so this question here is asking us to define all the variables you are using in the following situation and then write a linear equation to represent the total cost. The cost of building the project at a school consists of $1,000 fixed cost to cover the materials used and the variable cost of labour, which is calculated by a fixed rate of $30 per hour. So the first thing that we need to do is to identify the variable. So we have a total cost is what we're going to get at the end. And let's let that equal C. We also have the hourly rate. And we'll let that equal H. Okay. We also need to identify the fixed costs. In this instance, a fixed cost is $1,000 for materials. And we also have $30 for labour. So now we need to make an equation for this. So obviously we've got the total cost at the end, then the cost for an hour times by the amount of hours plus the $1,000 fixed rate is what we're doing here. So I can simplify that because I don't need to put a times by between the 30 and the h, because we know that if I just write 30h, that means times by h plus 1,000, and that is how I complete that question there. For this question we're given the following information. A tap was left dripping at a constant rate. The number of litres of water wasted is shown in the table below. First of all, we're required to plot the points shown in the table and join them to form a graph of this relationship. We need to label the x-axis with number of hours a tap was left dripping D, and we need to label the y-axis with the number of litres wasted W. So first thing we're going to do is label axes, which will look like this. After our axes are labelled, we need to plot our points. The first one is 0, 0. So I'll plot that there. Then I need to go to 2 and 10. Then I need to go to 6 and 30. And finally 11 and 55. So then what we need to do is to draw a line from the first point, 0, 0, to the last point, 11:55. And this will look like this. From these points we can also see that the line goes through the other two, and from this we can answer question B and conclude that yes, the graph is linear. Okay, this question here is asking us to use the graph to decide how much water would be wasted in 3 hours, 8 hours and 12 hours. And this is just a straight intersecting graph one. So if I look at this axis here, it tells us the number of litres wasted. So this is going to be the axis that gives us our answer. And this one over here tells us the number of hours. So the first thing I need to do is look at the 3. So I'll go to the 3 hours. draw a line up, it's going to intersect my line, draw that line across, and from there you can see that it will cut through 15, so that's my answer for that one. If I go to the 8 hours, just follow the grey line straight up, then straight across, get an answer of 40, and finally for the 12 one, go straight up, follow it straight across, and I'll get an answer of 60. There we go. So for this one here, same as the other one, what information do I need to find out and what information do I know? So for this one here, I know this information and I'm trying to find out this. So I'm going to be starting on this axis here. So the first one's asking me to follow the line across at 20 and then go down. Where does it intersect? So it's telling me that 4 hours. If I go to 35, don't have a line, but I've got a dash to follow. Follow that across, follow that down, go through 7 hours. And for the 45, go across, go down, and end up at 9. This question here it's asking, is it sensible for us to join the points in this situation? And for that, really you need to look at what the variables are measuring. And because it's measuring time, it's basically we can say, yes, it is sensible to join up what else is happening throughout. So we can write down yes. So for the last example of this topic, we're asked to find out a rule that shows the relationship between the number of hours the tap is left dripping, D, and the number of litres of water wasted. So our end result's always going to be these ones here, so that's the answer. So that's what it's going to be equaling. So W is going to equal something. And if we follow what we've spoken about before, rise over run, because we've got a 0, it makes my rise and run very easy. And my rise is always going to be my up and down axes, and my run's always what's going across. So I need to look at this value first. If I do 10 take 0, I'm going to be given 10. And then it's going to be the x, or this axis here, on the bottom. So my 2 times by D. And then, because it goes through 0, 0, I don't have a y-intercept, so I'll just leave it as it is. 10 divided by 2 gives me 5. So I have 5 times D equals W. And I can go through and double check the other ones. So 2 times 5 equals 10, 6 times 5 equals 30, 11 times 5 equals 55.